All right, today we're going to talk about something that is happening constantly to everything, everywhere. I'm talking about change. We're going to pull back the curtain and look at the hidden rules that explain how a melting ice cube, a growing plant, and even the stars in the sky are all part of the same incredible story of transformation. So think about it for a second. An ice cube melting on your counter, a banana going from green to yellow, a teenager suddenly shooting up a few inches. On the surface, they seem completely unrelated, right? But what if they're all just playing by the same rule book? Let's figure out what they have in common. Okay, first up, everything changes. From tiny little shifts to massive transformations, change is literally all around us. So let's start by just looking at what these changes actually are. I mean, you see it every day. A flower bud slowly opening up, a glass of ice-cold water that eventually just warms up to room temperature. Our world is in a constant state of becoming something else. But here's the key question. Are all these changes the same? Let's break it down. Well, it turns out we can pretty much sort every change into two big categories. First, you've got physical change. This is where stuff changes its form, but it's still the same stuff. Think about water. Ice, liquid, steam, it's all still H2O, just in a different outfit. But then you have chemical change, and this is a whole different ballgame. Here, the atoms actually rearrange themselves to create a brand new substance with totally different properties, and you can't just easily go back. So to really see how these new substances get made, we have to zoom in. I mean, way, way in, down to the level of atoms and molecules. This is where the real action, this incredible molecular dance, is happening. And you know what? We don't even need a fancy lab for this. We can whip up a classic chemical reaction with stuff you probably have in your kitchen right now. Okay, this one's a classic. You take a little bit of vinegar, add a pinch of baking soda, and what happens? It immediately starts fizzing and bubbling like crazy. Now, the crucial thing to get here is that those bubbles are the proof. They aren't just air. They are a completely new substance, carbon dioxide gas, being created right there in front of your eyes. That's a chemical change. And then there's one of the most powerful and common chemical changes of all, combustion. You and I just call it burning. It's this super rapid reaction with oxygen that unleashes a ton of energy as heat and light. It's what powers our cars and what warms us by the fireplace. Now for section 3, the engine of life. Because these chemical reactions we're talking about, they're not just for science experiments. They are the very engine that powers every living thing, including us. Ha! We've all been there, right? Some relative you haven't seen in a while points out how much you've changed. Well, all those transformations we go through, especially in our teenage years, are just a perfect example of biological change, and it's all driven by this incredibly complex orchestra of chemical reactions. And this table shows you exactly how that growth is just applied chemistry. The food we eat provides the building blocks. The calcium and proteins you get from things like milk, they literally help build your bones. The iron from spinach helps make your blood. And carbs, they're the raw energy that makes the whole construction project happen. It's a direct chemical input for a physical result. I mean, our most basic life processes are just a cascade of these chemical changes. Digestion, that's your body breaking down complex food into simple little molecules it can actually use. And then respiration is the process where our cells take those molecules and turn them into usable energy. It all comes down to this one molecule, ATP, which is like the energy currency for everything your body does. Okay, section 4, the rules of motion. So we've seen how things change, but what causes change to happen in the first place? What's the trigger? To answer that, we have to zoom out, way out, from chemistry to the universal laws of physics. And the core idea here is something called inertia. Honestly, you can just think of it as an object's stubbornness, or even its laziness. Things want to keep doing whatever they're already doing. If they're sitting still, they want to stay still. If they're moving, they want to keep moving. The only thing that can change that is some kind of outside force. And you know this feeling. You felt it a million times. You're on a bus, it's just cruising along, and then the driver slams on the brakes. And what happens? You lurch forward. So what is actually going on there? It's inertia in action. See, the bus stopped because the brakes applied a force to it. But nothing applied a force to you in that exact same moment. So your body, thanks to inertia, just wants to keep moving forward at whatever speed the bus was going, right up until you grab a pole or stumble into the seat in front of you. And this isn't just some quirky little feeling. It has really serious, real-world consequences. It's exactly why you have to tie luggage down to the roof of a car. If you brake hard and that suitcase isn't strapped down, its inertia is going to keep it going right off the front of your car. That's physics. And this isn't just an idea. We can actually calculate it. Using Newton's second law, F equals ma, we can figure out the precise amount of force you need to overcome that inertia and create a change in motion. So for this example here, it's 10 newtons. The big idea is that change isn't random. It follows predictable, mathematical rules. And that brings us to our final section, the candle and the cosmos. We've gone from the molecular level to the biological to the physical. Now let's tie it all together with one simple object that connects everything we've talked about. The legendary 19th century scientist Michael Faraday knew this. He believed that a simple burning candle was the perfect object to begin any scientific study because it contained so many of nature's biggest secrets. And here's why he was so right. A burning candle is where it all comes together. It's a perfect two-act play. First, you get a physical change. The solid wax melts into a liquid, gets pulled up the wick, and turns into a gas. But then, immediately, you get the chemical change. That hot wax vapor reacts with oxygen in the air, it combusts, and creates brand new substances, light, heat, carbon dioxide, and water. It's both types of change happening together in perfect harmony. And that really is the whole point. A chemical reaction, a growing teenager, a moving bus, a burning candle. They might seem like they have nothing to do with each other, but they do. They are all just different expressions of the very same fundamental rules that govern our entire universe. You know, understanding these rules gives us incredible power. The power to create new materials, to help things grow, to engineer our entire world. The principles are there, they're clear. The only question left is, what are we going to do with them?